Alright, so today we're going to look at how to control motors using Robot C. So the very first thing you're going to do is the same thing we do every single time. You're going to go to Robot, Platform Type, and you're going to make sure that VEX 2.0 Cortex is selected here as well, and Natural Language PLTW. Now it's time to configure our ports. So go to Motor and Sensor Setup, and we're going to start with our digital sensors. Alright, we're going to start with our digital sensors, and we're actually, port 4, we're just going to say there's a bumper. That's a touch sensor. And now we're going to go to motors. Let's apply that first. Motors, and we're not going to use port 1 of our motors because when you look at your VEX Cortex, it's actually a 2-pin port, and that makes it a little bit different than all the other ports. So we're actually going to just use ports 2 and 3, especially today. We're going to name this one L motor and this one R motor, and we'll capitalize M on both of those. And our motor type is a VEX 393 for both of those. Now, this is a really important thing right here where you can select reversed. Sometimes when you mount a motor, the direction that you mount it will make it change which direction it'll turn. And if you have a robot and it's not moving correctly, you can come into here and choose the motor that's turning the wrong direction and reverse it, and that'll make it where your robot will move forward or backward correctly. And it's pretty easy to watch for if you program your robot to move forward and it's turning one way or the other. Instead, you can reverse one of those motors and that'll fix your problem. Alright, so right now we're going to say neither are reversed. We're going to click Apply, and we're ready to code. So the first thing that we're going to do is let's look at how to control a motor. And there are a few basic lines. The first one is start, and if you look right here, it's start motor with a capital M, lowercase s. And in here we're going to go right motor, comma, and then 120. And let's look at this line of code. So we're going to compile it, and we'll just save it right now. Let's look at this line. So we're saying start motor, and we're saying, hey, start the right motor, and right here is the speed. So the speed defines how fast the motor is going to go. It's anywhere between 0 and 120, 120 being the max. All right, so now I'm going to start my next motor. I'm going to be lazy. I'm just going to copy this, paste it in here, and I'm going to start my left motor. So now I've started both motors, and once I've started them, I want to wait for, we'll say 5 seconds. And then the next line that we're going to use is stop motor. So stop motor, and then you would choose L motor, which is your left motor, and you can do it again for your right motor. So what we've done is we've started the motors, waited 5 seconds, and we stopped the motors. And that's all of that code. The great thing about motors is you can control them a little bit differently. So like, let's say I wanted to turn to the right. And when you think about a robot, the robot has 2 sets of motors connected to each wheel. So to turn right, what I can do is I could either just turn on the left motor. So I could just turn that on, and it's going to just run the left side, which will make the whole robot turn right, which is one way. But another way to do it is to make the left motor go forward and make the right motor go backwards. So what you can do is you can come in here and you can put a negative symbol right here, and that'll say, hey, take the right motor and make it go backwards and the left motor go forward, and that'll make the robot pivot in one spot. It's a lot like those 0 turn radius lawnmowers where you'll see the people pull the handles forward and backwards. This would be like pushing one forward and pulling one backwards so they turn quickly, and then you would have to figure out how long you would want it to turn to get the turn that you want. So like if I had it turn for 1 second, that'll probably get me close to 90-degree turn, which is great. And these lines of code work really, really well. But we also have to talk about controlling our motors, because every motor has its own special things that you have to worry about. Every robot is a little bit different. So let's say that I have this code here, and while, lowercase w, while sensor value, can't remember if that's lower or uppercase, sensor value, there we go, sensor value, and we're going to say bumper equal 1. So while this bumper equals 1, the left motor is going to go forward, the right motor is going to go backwards, so it'll turn right. Let's compile our program. Let's see here, what's it upset? Oh, we missed a bracket. And I think it's, there we go. So while the bumper equals 1, it'll run this code. While, actually we're just going to copy this. While the sensor value equals 0, we'll just say that the motors are both stopped. All right. Now, this could be code that was used in like a robot. Like let's say you have like a Roomba or something like that, and the bumper is the sensor on the front, and it hits a wall. This would just make the whole robot turn to the right, and then he would stop in this case. It'd probably be more beneficial for our robot if instead of stopping, he started to move forward from that point. All right, so this is the code that I want you to type and try on your test bench. You should see when you press the, oh, and we need a while 1 equals 1 in here, so that our code runs forever. So what will happen with this code is your robot will move forward until you press the bumper on the front, or your bumper switch, at which point one of the motors will switch directions, so your robot would turn. And this would be a simple code. This is what I want everybody to code and turn in. This will be what you turn in tomorrow. Let's look at some other code though. So we're actually going to go over here. And we're going to look at callouts or functions. This is a different way of programming. So up here where it says void turn left, this is actually a small little program within your program just for turning left. And then right here we have void turn right, which is a small program just for turning right. Okay, and if you look here, you make a small change. That one should be negative. No, that one should be positive. This one should be negative, and there we go. So this one's for turning left, this one's for turning right, and this one's for going straight 1 foot. All right, and what's really cool about these functions, these callouts, is instead of programming the same thing over and over and over again, you can go in your task main and you can literally just say straight, and it's going to go, hey, I need to look for something called straight. It's going to come up here, and this is the code for moving straight 1 foot. And you can see here I've got it going straight, straight, straight. So that'd be 3 feet, then it turns right, straight, turns right again, straight, 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 and then turns left. That would run the robot through like a basic maze. The big positive to this and why I introduce it during motors is because this same code right here, which is really clear and concise, and you know that you want to go straight 3 times, turn right, straight, turn right, straight, 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 and then turn left. This same exact code to do this the other way would look like this. When you look at this, this is hard to read, it's hard to understand. You wouldn't really know what's going on, and it's real easy to lose your way in your code. Like if you had your robot running through the maze and then it accidentally turned right instead of left and you needed to fix it, you'd have to go through this and be like, wait, where is it? What's going on? By doing callout functions, which are right here, by calling out and going just to this line of code, you can do this for everything. So instead of, like, if you had a blinking function or just about anything that you know you're going to want to repeat regularly, here is the way to do it. All right. So what I want everybody to do today is I want you to mess around with the code, see what you can get. Tomorrow, you're going to program this code right here. All right.